Shoot, apparently that thing only records for 15 minutes. So here's my second part of that recording. I can't remember where I was, but we have our intersections, right? That's our limits of integration, 0 to 6. And then we need our P and our H. So our P is the distance from the axis of revolution over to any one of those rectangles. So if our axis of revolution is the y-axis, then over to any of those rectangles here, the distance from this rectangle, this rectangle, this rectangle, any of those rectangles, looks like it's just whatever x is. So that would be my P, is x. My h, my height, is the height of all those different rectangles, right? And so we want to figure out how high each of these rectangles is. Well, it looks like to me the height of those rectangles depends on that area in between, right? The distance from the top function to the bottom function. So I want to figure out top minus bottom. The top function was the 6x minus x squared minus that other function, which was the x squared, ooh, that's supposed to be a plus 6. The x squared minus 6x, but make sure that you distribute the negative through, right? And so then when you do that, you can distribute the x, combine like terms, and evaluate there, and that should give you the volume of that solid. So disk or washer is when they're perpendicular, shell is when they're parallel, okay? Number 7 asks about average value. Average value, just like when you think about any average, is you're adding them all up and dividing by however many there are. So integrating is you're adding up all the area of the rectangles, and now you just have to divide by the interval. And so on this one, we have the function x squared times the square root of 1 plus x cubed, and we want to find the average value over the interval from 0 to 2. So we have to integrate our function from 0 to 2, but then we want to divide by our interval, which is 2, or I can multiply by 1/2. So that's where the 1/2 came from. Here, I'm going to do some u substitution because I noticed that I have a lot of stuff inside here, and so I called u 1 plus x cubed. The derivative then du is 3x squared dx. Well, I have an x squared dx, I just don't have a 3. So if I put a 3 in there, I would have to balance it out with that 1/3 in the front. So then that actually gives me a 1/6 in the front. I have my u to the 1/2 power, and then my du is the rest of it. Now you notice that my limits of integration changed from 0 to 2 to 1 to 9. At the beginning, when I had 0 to 2, these were limits with respect to x. But then we started doing u substitution. And so when you do u substitution, you can either change those limits of integration or you can keep them 0 to 2. Just make sure that after you integrate, you back substitute in your 1 plus x cubed before you plug in the 0 and the 2. Or what you can do at this point is change them to u limits and just substitute in at u's. So if x was 0 and I plugged in 0 here, excuse me, if x was 0 and I plugged in 0 there, then u would actually be 1. So my new lower limit would go from 0 to 1. If x was 2, my upper limit was 2, and I plugged in a 2, 2 cubed is 8, 8 plus 1 is 9, so my new upper limit went from 2 to 9. So that's how I got the 1 and the 9. You would integrate this just like normal, so adding 1 to the exponent and dividing by that new exponent. Don't forget your 1/6 out in front, and then from here you would plug in your 1 and your 9, or I should say your 9 and your 1 and subtract. So instead of plugging back in the u's and the 0 and the 2, you could just change it from 0 to 2 to 1 to 9 and plug in 1 to 9 into your u. Hopefully that makes sense. So that's that one. On this one, you're finding again the average value. So your interval is from 0 to the square root of pi. So I'm going to multiply by 1 over the square root of pi, or dividing by the square root of pi to find my average value. I'm integrating from 0 to the square root of pi, my function. It looks like a little bit of more stuff inside, so more of like a chain rule type of thing. So I'm going to call u x squared. That means du is 2x dx. Well, I have an x and a dx, I just don't have a 2. So I'm going to put a 2 in there and balance it out with a 1/2 in the front. When I substitute in my u, I end up with a new integrand of sine of u du. And so the antiderivative of sine of u is negative cosine of u. And then again, you can change to u limits if you would like to. If you plug in a 0 here, 0 squared is 0, so that kind of stays the same. If I plug in the square root of pi, the square root of pi squared, the square and the square root cancel, and I'm just left with pi. So now you can integrate and evaluate from 0 to pi just using your u's. That was number 8. Number 9 through 14 are calculator problems. So I'll have to figure out a way to show you my calculator and my screen at the same time as we're doing those ones. So I'll make another video for that. Hopefully these videos are helping, but if you have more questions, please let me know.